right, guys, 7.4, solving logarithmic equations. Let's go do this before the lights go out. Log base 9 of x equals 3 halves. First thing, as always, rewrite it as the inverse. So we're going to go ahead and take 9 to the 3 halves power is equal to x. So there's the exponential. And then after that, we're going to go ahead and take this 9, which is our base, and reduce it into primes. Well, 9 is 3 squared, because it's 3 times 3. But I still have 3 halves as my original exponent. So now I'm going to go ahead and simplify this. Well, 2 is a whole number. I got to put it over 1. And then I end up with 3 to the 6 halves as my exponent. 6 halves keeps reducing to 3. Well, 3 to the 3rd power then is going to leave me the answer of x being 27. So rewrite it into exponential form, change the base into primes as best you can, and simplify your exponents to solve for x. Let's take a look at the next one. This is our last example, solving for x. We notice that both of these have the same base. Well, if they have the same base, we don't need to change them into primes. We can go ahead, or honestly, we don't even have to do inverses. We can just go ahead and take the what the base of 3 is in each case, each on the left and the right, and solve for x. So I normally would solve for x, but there's an x squared. We've done hopefully enough of these where we have to set it equal to 0. X factor off to the side. Factors of negative 15x squared that add up to negative 2x. We need to find what times and what adds to it. Well, we have 3x and negative 5x work. So we bring down the initial term and then the last term. We GCF each of these terms. So we end up with x plus 3. Here we end up with negative 5, x plus 3. That is a sloppy 3. Let me try this again. And then we notice that we have the common GCF of x plus 3, and what's left is an x minus 5. So when we go to solve these, we end up with using the zero product property. X plus 3 equals 0, x minus 5 equals 0, ZPP, zero product property. Continue to work these out. We end up with x equals negative 3, x equals 5. The one to go to is always the one with a positive value, so x equals 5 will be the answer. We can't have a log of a negative number, so that one it will be discarded. So our final answer will be x equals 5. Hopefully this helps. Keep in mind the domains can only be positive, so therefore x equals 5 would work.